This video looks at Pythagoras Theorem questions in 3 dimensions. Some tips that will help you when doing examples that involve working in 3 dimensions are: make your diagram large, neat and clear, draw your base plane obliquely, mark in right angles, and redraw each triangle separately when you're working with it, straightening out obliquely drawn triangles. This example asks us to find the longest needle that will fit into a box which measures 6 meters by 9 meters by 2.5 meters. The longest needle will fit diagonally across opposite corners. Now when you draw that in, you'll notice it's not even in a triangle at all, but we could make a triangle here going up the edge of the box and across, and that'll be a right-angled triangle, right-angled at the bottom of the box. But it's not a triangle that we know much about. We do know the height is 2.5 meters. So, as in many questions like this, you need to look at another triangle which you know more information about. If we look at the triangle in the base of the box here, we do know quite a bit of information about this. We know it measures 6 meters by 9 meters. We could use that to find out that distance diagonally across the bottom of the box, and then with more information about the red triangle, we'll be able to work out the length of the longest needle as required. Label the important points A, B, C and D. Start by looking at that blue triangle. It measures 6 meters by 9 meters. We can work out its hypotenuse y. Y squared equals 6 squared plus 9 squared. Do a little bit of work and come up with y equals 10.81. Now we can look at the red triangle. We know that across the base of the box, CB measured 10.81. We can work out x. By Pythagoras Theorem, x squared equals 2.5 squared plus 10.81 squared, and do some more calculations to come up with the length x, the longest needle, equals 11.06 centimeters. A light wind has blown a sky lantern 205 meters to the east and 180 meters to the north of its initial starting point. The straight line distance to the top of the lantern is 620 meters. We need to find the vertical height of the lantern. The first thing is to draw up a diagram. Now when we do this, we make our base plane oblique, so one line is pointing to the north and the other is pointing to the east. Put our other bits and pieces in. We need to find out the height of the lantern, but you'll notice that in that red triangle, which includes the height, we don't know a lot of information there. So we have to look at another triangle, the one in the base plane. We know more information about that. We can use that triangle to work out distance x, and then we'll know enough information to be looking at our red triangle. So in the base plane triangle, we can say x squared equals 180 squared plus 205 squared. By Pythagoras, we can come up with the distance x. Then we move to the red triangle. It's another Pythagoras Theorem question. We've got the hypotenuse is 620, so 620 squared equals 272.81 squared plus h squared. By Pythagoras, we can work out that the height of the lantern is 556.75 meters.